you would just memorize the bromination reaction. Now what you have to do is you have to understand why that reaction takes place in the first, uh, in the beginning. So I'm going to start with the very basics. We just did chemical bonding. So I'm going to start with carbon. And we talked about carbon bonding in different ways. Organic compounds are compounds that belong to living organisms mostly. Chemistry of life is all revolving around carbon. Okay? We are carbon compounds, animals, plants, etc. Everything living are carbon compounds. Carbon is a very versatile atom because it forms a lot of bonds. So it's good for making structures. It makes four bonds. And it makes four bonds in many different ways, in many different shapes as well. So it's if you want to make a complicated structure like a cell or like a DNA molecule or like your skin, carbon is very it's a very suitable compound. So carbon bonds in three ways. One is that it could be sp3 hybridized, which means that carbon would be bonded to four atoms, and it's going to have a tetrahedral arrangement. Okay, we just did hybridization recently. So it's going to have its four electrons in its outer shell are going to be pulled in different directions by four atoms. Okay, let's call that atom X. The shape is going to be tetrahedral and the angles are going to be 109.5 degrees. The second way that carbon bonds is called sp2 hybridization, in which, so now in sp2, unlike sp3, carbon is actually bonded to just three atoms. So the shape of carbon is like this, that one of the electrons of carbon gets pulled by one of the atoms, the other one gets pulled by another atom, the third one gets pulled by the third atom. So it's fan shaped, it's trigonal planar. And the angle is 120 degrees. And what happens to the fourth electron? No one is initially interested in this fourth electron, which is a p orbital. Okay, if I just for recall, if I write the electronic configuration of carbon, carbon has a total of, so carbon has a total of four orbitals. It's in its outer shell. It has 2s1, 2px1, 2py1, and 2pz1. So four orbitals. So in sp3 hybridization, all the orbitals they get stretched by four different atoms. The electrons get pulled in different directions, so that's tetrahedral. And whereas in sp2 hybridization, it's only bonded to three atoms. So one orbital gets pulled by one of the atoms, the other one gets attracted by another atom, and the third one gets attracted to the third atom. So three of the orbitals they change shape. The fourth one remains completely unchanged. And this p orbital is involved in pi bonding. Okay, this one is involved in forming pi bonds. And we will study pi bonding in detail a bit later as well, because that's very, very important, especially when you're talking about alkenes. Now, the third hybridization was sp hybridization. Now, in sp hybridization, carbon was only bonded to two atoms. So carbon had a total of four orbitals. Uh, but in sp hybridization, Ibra, your mic is on. So now in sp hybridization, two of the orbitals they get stretched in different directions. Okay, one of them gets pulled by one of the atoms, the other orbital, the other electron gets pulled in the other direction. While two of carbon's orbitals, they kind of remain unchanged. So two of the p orbitals they remain completely unchanged. So this is your z-axis, and there's going to be an orbital that would be lying on the z-axis as well. Okay, so out of the four orbitals, when carbon is only bonded to two atoms, one of the orbital gets stretched, forms a sigma bond with one of the atoms. The other orbital electron gets stretched and bonds with the other atom. Two of the orbitals they remain completely unchanged, and these two orbitals are capable of forming two pi bonds. Okay, they form two pi bonds. This is an example of such a molecule as carbon dioxide or an HCN molecule. And just for revision's sake, okay, so that this is clear, we did this somewhere over here. Let me just quickly show you. I said this was shapes just before this. So this is sp hybridization. So out of the 4 orbitals, one orbital gets stretched by one of the atom, the other one attracts the other atom, and these orbitals, they're involved in forming pi bonds. I mean, this is where I showed. Okay, this is how it's happening. This is carbon bonded to oxygen. Oxygen pulls one of the orbitals. This oxygen over here pulls the other orbital. And the 2 orbitals, the red and the blue ones that are remaining, they end up forming a pi bond, a double bond over here and a double bond in a different plane, but on the left side. This was an HCN molecule. You had a carbon atom. The H pulled an electron over here. One of the N pulled an electron over here. So that's 2 sigma bonds. 2 of the orbitals of carbon, they remain unchanged. They were p orbitals, and they would end up forming pi bonds with nitrogen. So 2 pi bonds were formed, and a triple bond was formed on this side. So anyways, right now you just need to know what the shapes are. You just need to know how carbon is going to bond. We're going to talk about this in detail a bit later. Just one second.
Sir, can you briefly explain this sp3, sp2, and sp subshells?
I was just going through this quickly because we had already done this. I'll just quickly explain. Very quickly. Ibrar, carbon has 4 electrons, right, in its outer orbital. There are 4 orbitals.
Yeah.
In its outer shell, there are 4 orbitals. Each one has an electron. Hybridization is simply that when an atom is bonding, it has 4 electrons. The electrons are going to get pulled by the other atom. Why is the other atom attracting? Because its nucleus, it needs an electron. Its nucleus would attract this electron, right? So it's going to pull that electron over here. So what would happen is, what would happen is that all the shapes would change. S was a spherical orbital, which means that the electron existed in a spherical region. Like if the electron gets pulled or gets attracted by one of the atoms, तो उसकी shape जो होगी, that's going to be different, right?
Exactly.
So this is what happens. This is the shape of the 4 orbitals. You still have 4 orbitals, but the electrons, one of the electron gets pulled over here, the other one gets pulled by the other hydrogen, the third one gets pulled, fourth one gets pulled. So all of them, their shapes change, and their shapes change, which is why you give them different names. Because you can't call them S or you can't call them P. Because P or S, the shape hoti thi, that was a very specific shape. So the new names for these orbitals are sp3, 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 and sp3. Okay?
All right.
And this is how carbon would look. The second.
Sir, why is it not sp2 over here instead of sp3?
It's just a name. There's no logic behind the name. Somebody had to give it a name, so just started calling it sp3. What that simply means is that the S and all the 3 Ps, they've all changed shape. Otherwise, the name is completely irrelevant. Somebody just started calling it sp3 hybrid orbitals. Anyways, sp2 hybridization is when carbon has 4 electrons, 4 orbitals, but now only 3 atoms are bonded to it. So one gets pulled over here, one gets stretched over here. The fourth one, no one is attracting the fourth one. Is this clear?
Yes.
So you have 3 sp2 hybrid orbitals. I mean, the S, Px, Py, they've changed. You give them different names. The fourth one remains completely unchanged. So you still have 4 orbitals. But one of them hasn't changed shape. What happens with this orbital that's not changing shape? That ends up forming a pi bond. So you have a carbon over here. One electron gets pulled over here, one over here, one gets pulled by the other carbon atom. Your fourth electron, that's no one is pulling that. And that fourth orbital ends up forming a pi bond with the neighboring carbon atom, which is exactly the same. Okay?
Oh, so basically 3 atoms are bonded to carbon in sp2.
Yes. So three,
Acha, all right.
let's say it's fan shaped, it's trigonal planar, the angles are 120 degrees. The fourth orbital, which is initially not bonded, not forming a sigma bond, वो फिर क्या करता है? It ends up forming a pi bond. ठीक है?
All right.
And I also explained graphite. Okay, graphite ke andar you have lots of sp2 hybridized carbon atom. That every carbon atom, I mean, look at the three. Every carbon atom is bonded to three atoms. So three orbitals getting stretched in a fan-shaped manner. वो जो fourth orbital है, that's not doing anything. And
Acha, all
each,
right.
and each of the carbon atom is exactly the same. ठीक है? And the end result is that you have lots of p orbitals which are parallel to each other. And they would start pulling each other, they would start attracting each other, they would start overlapping, and the end result is they would all start overlapping with each other. So you will have a delocalized electron cloud.
All right.
ठीक है? मतलब in a double bond you don't have a delocalized electron cloud. मतलब the electrons are very localized. They're just over here. But if you have lots and lots of p orbitals which are parallel to each other, then the electron cloud would become delocalized. It would be everywhere. ठीक है?
All right.
Okay, ये last था. This was sp hybridization which we did. In this, carbon is only bonded to two atoms. I mean, this was an oxygen atom, this was the other oxygen atom, this was the carbon in the middle. So one electron gets pulled, the red arrow is one electron gets pulled in this direction, the other electron gets pulled in this direction. And the two of the orbitals, one on the, let's say this is the y-axis, this is the z-axis, okay, they remain unchanged. And they are involved in forming two pi bonds. So in carbon dioxide, it forms a pi bond with one oxygen, and the blue one forms a pi bond with the other oxygen atom. Okay, is this clear?
Yes, sir. Yes, it's clear.
चले ठीक है. किसी ने if somebody still wants to study or revise तो उनको भी separately ना I can go over hybridization again. ठीक है. What you just need to know right now is the shapes. The last one is 180 degrees and it's linear. Achha, so this is hybridization of carbon. You must know what the shape of the molecule is going to be. Okay, if it's bonded to three atoms, it's going to be fan-shaped, which is trigonal planar. Never write fan-shaped. If it's bonded to four atoms, it's tetrahedral, and if it's bonded to just two atoms, then like in carbon dioxide, then it's going to be 180 degrees and it's going to be linear.
Sir, so would the angle be affected by a double bond or a single bond?
Obviously, it's going to be affected very slightly, actually. Okay. Like if you have an ethene molecule, okay, carbon is only bonded to three atoms. It's going to be fan-shaped. But remember, double bonds. I mean, look, focus on this carbon atom. Okay, around the carbon atom, the angles are going to be 120 degrees, but the double bond is going to exert a slightly greater repulsion, which is why these two bonds would be very slightly closer together. Let's say it's 119, or you can simply write slightly less than 120 degrees. Okay, Ibrar, is this clear?
Yes, sir.
So the angle gets drastically affected if there's a lone pair, because lone pairs exert a greater repulsion, but carbon doesn't have lone pairs. Whenever carbon bonds, all its electrons get used in bonding, so there are no lone pairs. Now the next thing, something that's very, very basic, and that is we're going to talk about formulas. Okay, before doing anything, we're going to talk about formulas. There are different types of formulas that organic compounds can have. The first one is a molecular formula. And then you have structural formulas, then you have skeletal formulas, then you have three-dimensional formulas. Now, whenever you make an organic molecule, you need to make the correct version of the molecule. And how do you figure out the correct version? You must know which atom forms how many bonds. So for example, group 7, remember they always form one bond. Usually they form one bond. You have group 6, they form two bonds. Group 5, they form 3 bonds. And then you have group 4, they normally form 4 bonds. Okay, and I'm going to write a few atoms over here like fluorine, chlorine, bromine, and iodine. Um, in group 6, you have oxygen and sulfur. In group 5, you have nitrogen and phosphorus. And in group 4, you have carbon and silicon. So if I draw any random structure, okay, that's the first thing. We're going to talk about the structural formula first. So now, what's a structural formula? Um, it simply shows you the structure. It shows, or simply we can say that any formula, I mean, there are many ways to write a structural formula as well. Any formula that shows the arrangement of the atoms. Or connectivity of the atoms. I said, remember what a structural formula does not show. Does not show the three-dimensional arrangement. It does not show you the angles. Okay? All that information is actually missing from a structural formula. For example, if you have C, which is bonded to 4 hydrogens, if you have C bonded to 4 hydrogens, it just shows which atom is connected to which atom. It doesn't give you that the shape of the molecule in reality is going to be this one, that it's going to be tetrahedral. Okay, so that is what a three-dimensional formula does. So structural formula just shows you which atom is connected to which atom. So it doesn't really matter if when you're drawing a structural formula that this H is at the bottom. You could have both hydrogens pointing upwards. I mean, it's irrelevant. It's still the same connectivity. So remember, when it comes to structural formulas, bending a molecule or rotating a molecule, flipping it around, whatever, okay? Rotating, flipping it, doesn't change the molecule. I mean, you would be drawing the same because you're not actually drawing the three-dimensional formula. Your molecule remains exactly the same. What I mean by this is, let me show you with an example. What I mean by this is, like for example, if you have 4 carbon atoms in a row, so this is one way to show or represent the structure of a molecule. This is a butane molecule. We're going to talk about naming later on. So this is butane. But if I draw this molecule like this, so if this molecule is drawn like this, now these two molecules, they kind of look different, but they're exactly the same molecule. Okay, they're exactly the same molecule. Okay, so never get confused. A lot of people get confused with this. Okay, they think they've drawn something, especially in isomers. When somebody tells them to draw isomers, they think this is a different molecule. It's exactly the same molecule. Because remember, the structural formula doesn't show you the three-dimensional arrangement. It doesn't show you, so it doesn't really matter as long as all the 4 carbon atoms are connected the same way. They're all connected together. So the 4 carbon atoms over here, 1, 2, 3, 4, they're connected exactly the same way. The first carbon atom is connected to 3 hydrogens, so it is connected to 3 hydrogens over here as well. The second carbon atom is connected to 2 hydrogens, which is also true over here. This carbon atom is also connected to 2 hydrogens, which is again true. The last carbon atom after that is connected to 3 hydrogens. Okay, so always remember this, that bending, rotating, flipping a structural formula, as long as you're not breaking bonds, it won't change the molecule. You're just drawing the same molecule in a different way. Okay, is this clear? Abba, is this clear? Rida, Iba, Minahil? Basa, clear?
Yes.
Achha, so based on this, the very, very basic thing is you must learn how to draw. By just looking at a molecule, you must know that whether you've drawn a correct version of the molecule or not. Okay? Now, right now, uh, I'm going to draw an incorrect version of a molecule. I said, can anyone point out the mistakes in this molecule, in the structural formula that I've drawn? Like what's wrong with it? Based on the table that I've drawn over here. Anyone, any idea? Bhaska, any idea?
सर
Uh,
कार्बन के बहुत ज्यादा बॉन्ड्स हैं मतलब
हाँ ठीक है. But the first वाला तो ठीक है ना? The first one is right? I mean, it's fine. It should be making, carbon should be making how many bonds? It should be making 4 bonds. ठीक है, so that's fine. इसके साथ issue है. I mean, it's making too many bonds. It should be making just 4 bonds. So I'm just going to correct this. ठीक है, अभी I'm just making random corrections. Even now, it still has a total of 5 bonds. 3 are over here, 1 is here, 1 is here, so that's 5. So I'm going to get rid of another bond. Is this correct now or not? How many?
Correct.
ठीक है. How many bonds should N make over here? I mean, N is in group 5, right? It should be making 3 bonds. So it is making 3 bonds. A double bond over here and a single bond over here. ठीक है. So that's the first basic mistake that pretty much everyone makes, and that is that when they draw a molecule, so kahin na there's some place somewhere in the molecule they make too many bonds. Okay, make sure you avoid that mistake. Let's do another example. Okay, let's say I have this molecule over here. And I have lots of fluorine atoms, and I have to attach the fluorine atoms to this molecule to make the correct structure. How many fluorines should I connect with this carbon atom? The first one. कितने bonds बचे?
3.
ठीक है, so there should be 3 fluorine, sorry. The second one, how many fluorines?
2.
ठीक है, that's going to be 2. इसके साथ how many fluorines?
None.
ठीक है, and this one should be how many?
2.
ठीक है. अच्छा, what else? Oxygen, ठीक है? Is the oxygen correct?
Yep.
And I think this oxygen is also correct. It's making 2 bonds. This carbon should
Carbon
be
1.
ठीक है. अच्छा, is this point clear to everyone? ठीक है, you know, you've probably done this in O levels as well. Drawing the correct structures by just looking at a molecule, you should know what the mistake is. ठीक है, Ibrar, is this clear? Yes.
Sir, it's clear, but oxygen is making 2 bonds, but it's not completed in its octet.
Why isn't it completed its octet? I mean, it's supposed to make 2 bonds. But oxygen has how many? Oxygen is in group 6. It has how many electrons in its valence shell? It has 6 electrons. ठीक है?
Exactly.
So if it makes 2 bonds,
So,
so एक electron इधर carbon से है, एक electron coming from the other carbon. So that's 8.
how's that 8? Isn't it? Matlab, we still have lone pairs in oxygen, right?
हाँ, लेकिन I mean, let me draw this. This is oxygen in its original form, right? 6 electrons. How many
Yeah.
electrons? How many electrons does it need?
It needs two more. Acha, ठीक already. Yeah, I get it. सही.
एक इधर से आया, so it just needs to make two single bonds, right?
Yeah,
Or,
yeah.
or what could happen is it could form a double bond. ठीक है?
Exactly. सही.
अच्छा, so that's the first thing. We're going to practice this a lot because सारा हमने पढ़ना ही है, ठीक है? We have to study this a lot. So we'll be drawing correct structures. अच्छा, anyways, so this is what your structural formula is. But the structural formula has many different versions. I mean, there are lots of different versions of a structural formula. There's a thing called a condensed structural formula. I mean, that's not the name of the thing, but so there's a different way of writing the structural formula. As a condensed. Why condensed? Because it takes a lot of time to actually draw the atoms. Okay, it's time consuming, especially if you have a big molecule. It's time consuming to draw all the bonds. So what happens in a condensed structural formula? Let's start with the simplest. Okay, I have a molecule of propane, which has, I mean, this is the molecule. Now, instead of drawing all the atoms, what you could simply do is, the first carbon atom has how many hydrogens bonded to it? 3. So you just write C and H would be 3, right? The second carbon atom next to it, that has how many hydrogens? It has 2, so that's C, and then, sorry, where's the C? So that's going to be C with 2 hydrogens attached to it. The third carbon atom has 3 hydrogens, okay? So this is still the structural formula because it tells you the arrangement. It tells you all the information of which atom is connected to which atom. I mean, there's a carbon atom connected to 3 hydrogens. Then next, there's another carbon atom connected to 2 hydrogens. So you still have all the information is preserved, and you haven't drawn all the bonds, but you still know which atom is bonded to which atom. Okay, is this clear? Abha, is this clear? Bhaskar?
Yes, sir.
Yes.
So that's a condensed structural formula, but this was a simple molecule. How would you write a condensed version? Acha, why is the condensed version important? Condensed version is important because a lot of times, acha, when they ask you to write the structural formula, you could either choose to draw this thing. Okay? I mean, when they say write structural formula, it's your choice. Any formula that shows the structure, that is technically a structural formula. So you could draw all the atoms and all the bonds, or you could write a condensed version. That's your choice. But the problem is that they don't give you a lot of space. So you don't have the option to actually draw this entire molecule because it's going to consume a lot of space. I mean, if it's a one-line answer, you can't go about drawing a complicated structure. So well, your only solution would be to write a condensed version. Okay, you'll run out of room, out of space. लेकिन गलत नहीं होगा. The first one, even if you write the first one, that's still correct. Okay, so the word structural formula is any formula that, so it could be the first one or it could be the second one. But since you'll be limited by space, so it has to be the second one. So anyways, let's try and do a more complicated molecule. So let's make it more complicated. There's an OH group. There's a double bond O and H here. There's a CH3 over here. I say even थोड़ा और extend कर लेते हैं. There's a CH2. So this one would have, but I'm even condensing it. Let me draw the whole thing. So CH3, this one will have H, this one will have 2 hydrogens, this one will have 3 hydrogens, this one will have 2 hydrogens, this will have 3, or I think, is there anything else missing? It looks fine. Okay. Remember, by just looking at the molecule, you must know that there's nothing wrong with it. Okay, by just looking at the molecule. Okay, carbon, all the carbon atoms should be making 4 bonds, all the oxygen atoms should be making 2 bonds, and all the hydrogen atoms should be making a single bond. Acha, how do you condense this? How do you write it in one line? तो उसका rule ये कि pick a side. It could be the left side, it could be the right side. The side doesn't really matter, ठीक है? In my case, I'm just going from left to right. ठीक है? Start writing left to right. What's the first thing? That's a C with 3 hydrogens. ठीक है? That's it. I said, move to the next one. That's a C with 1 hydrogen. I said, so that's a C with 1 hydrogen. What do I do with this thing? That's called a branch. ठीक है? That's a branch, like a tree branch. You're going this way and there's a thing coming out of it. So that's a branch. So I'm on the second carbon atom. There's a C with 1 H. That is what I've written. Branches are written in brackets. So if you want to condense it, you're still stuck at the same carbon atom, right? I want to write everything that's attached to this carbon atom, but the branch has to be written in brackets. So what's the branch? The branch is CH2 and CH3. That would be written in brackets. Okay, that's the branch, CH2 and CH3. So now move to the next carbon atom. Okay, we're moving left to right. Again, that's C with 2 hydrogens. What's the next one? That's again a C, but now it has 2 branches. There's an OH branch at the top. Okay, remember, these are 2 different branches. There's a branch going on the top and there's a branch coming to the bottom. And there's a CH3 branch. So put the branches in brackets. Okay, that's what I've done. Yeah, clear? Is this clear to everyone? Minail, is this clear? Abba, is this clear? Rida,
Yes. Yes.
अच्छा, उसके बाद next carbon atom. What do we do with this? It's carbon with an oxygen. So just carbon with an oxygen, that's it. Next, what's coming after that? Another oxygen, okay? So that's... And what's after that? It's...
Sir, could we write O2 instead of double O?
You can actually write O2, okay? I mean, that would be even more condensed. I said this one. For this one, it's important to know, okay, I could write this in 2 ways. I could either write it in C and there's O and H. I mean, that is what it is. C with O and an H. So C with an O and an H. So I could condense this. But the thing is, this structure over here is always written as CHO. It's always written as CHO. And that's your condensed version. I've written the... I'm going to explain
Sir,
this.
where you wrote
How?
where you wrote this COH in brackets after CH2, could you also write it like CHO?
No, maybe I'll make a point. Okay, I'll explain this later. Okay. इस part को अभी छोड़ दो. The rest is clear, right?
Yes.
अच्छा.
Sir, why did you write COO? Why not CO2?
Which one?
Sir, the second last one from the right. You wrote
इसका क्या है
COO.
कि ये COH क्यों लिखा है? CHO क्यों नहीं लिखा?
नहीं सर, ये COO क्यों लिखा है? CO2 क्यों नहीं लिखा?
वो लिख सकते थे, कोई मसला नहीं है. C with 2O, CO2 भी लिख सकते थे. ठीक है, that's still fine. ठीक है, clear है? आर्यन. अच्छा, I'll just make 2 points. One is, अच्छा, I'll just make 2 points. Hopefully condensed version तो समझ आ गई होगी. Okay, how to write और किसी भी डायरेक्शन. You could have gone from right to left. ठीक है, it doesn't really matter. एक लाइन में पूरा मॉलिक्यूल आ गया. अच्छा, branches. 2 points are branches are written in brackets. Any branch जो top या bottom पे that's written in brackets. And the other thing is कि whenever you see this structure, ठीक है, this one over here, and only this one, this is the only one that has this confusion. Never write it as COH. ठीक है, that should never be written. It's always written as CHO. ठीक है. So C with 3 H's, C with H, followed by a branch bracket, CH2. So the rest is always the same. It always the same. Except कि remember this structure would always be written as CHO. ठीक है, we're going to practice this more in the next class. इसकी हम बहुत ज़्यादा practice करेंगे because a lot
Any
of times.
reason
हाँ.
कि इसको CHO लिखेंगे? Any reason? कि मतलब COH ना
हाँ,
जगह
वो मैं
CHO
explain करता हूँ क्योंकि जो OH होता है ना, OH, COH, OH is for alcohols. ठीक है, alcohols अगर if you remember कि it's a functional group, right? This is not an alcohol.
Yes, sir.
ठीक है, तो मतलब problem is कि if you write it as COH, so it looks like it's an alcohol. मतलब OH group is a functional group, ठीक है? So I mean there is no OH group here. So just to differentiate from alcohols, okay, this is not an alcohol, ठीक है? So it's instead when you compress it, you don't write COH, you always write CHO. Clear है आलियान?
Okay. Yes, sir.
चलिए ठीक है. चलिए ठीक है. We'll continue with this. We'll practice more questions related to condensed structural formulas, ठीक है? In the next class. Okay then. Take care. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.